Okay, so we've got a problem here with a unit square, and in our square we've got an arc from a unit circle, and then also embedded within this, tangent to the arc and the other circle, we've got a little circle here, we've got another circle here which is tangent, just touching the sides of our square. And we've also set this up so that these two small circles are as small as possible, and what this means is we're just avoiding any kind of situation where if you were to make this one slightly bigger, but not too big, you could still fit in another circle which is tangent here and tangent here and doesn't touch the side of the square, and they could still have the same radius. So we're just trying to avoid that scenario. Okay, so why don't you, if you want to have a go, pause the video now, and then we'll have a look at a solution. Okay, so first thing I'm going to do is draw a nice big diagram so I can label everything I'm doing. So we know this length here is 1 unit, we know that this length here is also 1 unit, and that means that we also know this diagonal length here is the square root of 2. Do 1 squared plus 1 squared, square root of that. And of course we'll draw in our other two circles now. So we know that this diagonal length here is the square root of 2. We also know that this length here is 1 unit, isn't it? Because this is just the radius of our circle again. And then if we call the radius of our smaller circles, we call this r. We've got r here, r here, r here, r here, and then a little bit left over there. So we could almost say that root 2 is equal to 1 plus 4r plus a little bit extra, and then deal with that and solve to find r. But that little bit extra is a bit of a problem for us. So what I'm going to do next is I'm actually going to draw in some extra lines. Okay, and these two lines are both perpendicular to the sides of our square, and you may have noticed the length of these lines is just the radius of our small circle again, isn't it? So we've got here r and r again. So what we've really got is a little right angled triangle of r, r, and then this means the hypotenuse has to be root 2r there. Okay, so what have we shown here? We know that this total length is the square root of 2, and we know that we've got r plus r plus r plus root 2r. So we can say that 1 plus 3r plus root 2r is equal to root 2, and then we can rearrange here to find the value of r. So we write r is root 2 minus 1 over 3 plus root 2. We rationalise the denominator here. We'll get r equals 3 root 2, and then we've also got minus root 2, so we'll have 4 root 2 minus 3 minus root 2 squared gives us minus 5, and then all over 3 squared minus root 2 squared is 9 minus 2, gives us 7. Okay, great. I hope you enjoyed that.